Nuclear Chemistry by Louisi and Filippi. What are gold's properties? Can we create gold? No, not by chemical means at least, only using linear accelerators. What is creating gold with a linear accelerator? Creating gold with a linear accelerator is an example of nuclear chemistry. Nuclear chemistry? What's that? Nuclear chemistry is a section in chemistry that involves radioactivity, nuclear processes, and nuclear properties. First, we'll talk a bit about the nuclear fuel cycle. There are three different stages of the nuclear fuel cycle: the front end, the service period, and the back end. So let's begin with the front end. The front end is a stage that prepares the fuel. It all starts with uranium ore, the principal raw material of nuclear fuel. Then, uranium is transported to a conversion plant in the form of yellow cake. Later on, uranium hexafluoride, or UF6, is used in enrichment of the fuel, which yields the nuclear fuel, a compact, inert, insoluble solid. The service period is the next stage. It is the period in which the fuel is used. This stage needs extra care, and it is very dangerous as nuclear fuel is very radioactive. So, it needs careful transportation and also needs careful management of the fuel. As I said before, it is very radioactive, so therefore it is very dangerous. Finalizing, we have the back end, which is responsible for safely managing, containing, and either reprocessing or disposing the fuel. If the fuel is only used once, it is disposed and the cycle is called an open or once-through cycle. However, if the fuel is reprocessed, which means used more than once, it is called a closed fuel cycle. This image sums up the nuclear fuel cycle. It all starts with the fuel fabrication. Then, as fuel rods, it goes to the reactor, and the used fuel is stored, either disposed or reprocessed. If it's disposed, the fuel's journey ends there. But if it's reprocessed, it may either go through vitrification and then disposed, or it can lead other paths. It can go in the form of plutonium to MOX, which is the fuel fabrication, and go to the cycle all over again. However, it can also be reprocessed and be converted to UF6, uranium hexafluoride. Then, the uranium is enriched and it goes again to the fuel fabrication, returning to the beginning of the cycle. Mining can also be converted into UF6, and then also go to the enrichment part and go again to the fuel fabrication and start the whole cycle, or it can become tailings. For your better understanding, I'm gonna say what tailings mean. Tailings is the residue of something. Some sediments could be refuse, waste, garbage, so we can say that the mining can also turn into tailings or waste.
Let's talk about fission. The basic concept of fission is described as when a neutron bullet is launched towards the nucleus of an element. Let's elaborate. During fission, a particle composed of 2 neutrons and 2 protons is launched towards the positive nucleus of an element. This particle is called alpha. But wait, why doesn't the positive nucleus repel the positive particle? Well, the neutrons that are represented in the particle have a neutral charge, and thus don't repel the nucleus, and they are the ones who attract the particle to the nucleus. Continuing, when this bullet hits the nucleus of the positive element, it scatters the nucleus's protons and neutrons, regrouping them in scattered locations. Fissile isotopes are isotopes of elements that can undergo fission. Fission is also commonly associated with nuclear bombs, since it is a process that is undergone in atomic bomb explosions, usually perpetrated using uranium. Since we have been talking about fission, I shall now briefly mention fusion. Fusion is basically when two light nuclei combine to form one nucleus, which is heavier than the originals. This reaction is what is actually used in thermonuclear weapons, since it releases an amount of energy 1,000,000 times greater than that of an average chemical reaction. We would like to thank you for watching, and have a nice day.